Thanks, Wendy. I think you got some good gusto. The talk really, I declare an environment. Excellent, excellent. Well, thanks for having me here, everyone, today. I am super excited to talk to you about something that is always my longtime passion of trying to make things more reproducible. And in particular with kind of some new cool tools that I've been experimenting with lately. We covered, I'm an experimental physicist by training, which is why I tend to treat everything in my life as if it's an experiment, including training with my dog. And I am local here in Seattle, so if you want recommendations for anything, restaurants, or like where are the best places to go floating out on the Sound, I'm the person to come talk to. That's Chewy, by the way. He did supervise and vet this talk, so just so you know, I've got managerial approval on this. So I always love hearing people's crazy computer horror stories. I know we had a talk this morning kind of about ways different computer systems fail. And these are legitimately all things that I've had computers do on me. From getting lost at a conference, I have had a computer that got plugged into the internet where the operating system was so old it caused illegal financial transactions to happen and the police came and took the laptop. Scientific equipment doesn't update very quickly, so Windows XP in the 2020s is probably not something you should plug into the internet. Or we just literally had an entire hole open up under the floor under the lab, right where we were standing working on the experiment. So thank goodness it was the computer and not us. And worst of all, they install updates. So then, all reproducibility things are off the table. So a question that I'm always coming back to and have been in my work, and also because probably like a lot of you here spend some of your free time working on cool software tools, projects. You probably don't want to do it over and over again just because something burns out or an environment gets blown away. So what's the best way to kind of reduce the amount of effort you're putting into making things reproducible? And because I know this is the 4:30 talk slot, I'm almost ready for nap time, so I'm going to give you the TLDR right here. So if you need the rest of this for a nap, please enjoy. But really what I've kind of been trying to articulate and spent a lot of time, spent a lot of lunches with my colleagues talking at them about what I'm really excited about. Reproducible environments really do kind of take specifying in both declarative and imperative ways. So those are kind of, I mean those in the general kind of programming paradigm ways. So what literally I need, packages I need, and what are the steps that you need to take to actually reproduce. And we have pretty good imperative solutions right now, especially for things that describe the whole system. That's Docker. I've had my Docker phase. Where I just put everything in Docker containers, but really that isn't necessarily always going to be a great solution. So I wanted to kind of share here with this talk a way you can kind of combine Docker, Nix, and a bunch of other different ways that you're probably already using to make things more reproducible to, well, make your Python projects or other software projects more reproducible. So I keep saying this word, reproducible. And in my mind, that's usually like, oh, reproducing a scientific experiment. We've got the scientific process. But kind of the shorthand that I try to think through when I'm trying to kind of assess how deep I need to go down a rabbit hole for a project is who do I think might need to reproduce this, on what sort of devices. Sometimes I really obsess over like, oh, it needs to be entirely cross-platform and, on ARM. And then it's like, well, actually, no, probably only these people will ever use it. I don't need to spend the time on that. When, is this going to be good till the end of the semester, or is this something that's going to go with a published scientific publication where I want people 5, 10, maybe 15 years in the future who actually might care about this to be able to reproduce it? And with what resources? So that's kind of a key one of, where are you getting your packages? Are you going to literally bundle everything about all your dependencies together with it? Are you going to say, oh, here, hope on effectively this package store still existing in 10 years to get things from? Those are kind of the bounding or scoping questions that I would go through when I'm thinking about designing a reproducible solution for a project. And then, well, we usually call whatever you come up with an environment. And there's kind of two ways to actually describe an environment. There are certainly more, but these are kind of like the two main categories in my mind. Declarative is like listing exactly what you have to have. Here's your shopping list of what you need to have to make this project. And imperative is generally a list of steps of how you actually went about making it. And I am probably quite certain you've seen examples of both of these types of tools or file formats or whatnot. So I was going to ask, because I always like finding out what other people are using, shout out, what's your favorite like packaging or like project management tool right now with Python?
Pip tools.
Pip tools? Sorry?
Python Path.
Python Path, that's another good one.
Pants build.
Pants build, yep.
Nix.
All right, Nix. Poetry, yep. And it's something that I think is kind of somewhat unique to Python, because there are other programming languages and frameworks, there is one tool. Like in Rust, there is cargo. There isn't like necessarily this huge ecosystem, and it's really neat. I enjoy looking at a bunch of different solutions like this that people have come up with, because they always address different problems or different like use cases or workflows. So I tried to like in my head, because it's very overwhelming. You ask anyone and pretty much you're going to get a different answer for like, oh, how should I manage this Python project? So I was trying to come up with like a way of organizing all of this in my head, and kind of came up with two axes here. One, the vertical here is declarative and imperative. So that's kind of that split between, am I trying to describe the results, or am I trying to describe how I got there? And then there's, on the horizontal axis, kind of to the left, simpler, I put simpler here in quotes, because it's just trying to describe like the Python parts of your project. And to the right would be kind of more advanced, like capturing like OS level dependencies or other things that might be outside of the scope. If you say had a Python project that wasn't pure Python. If you have a pure Python project, then you can live happily on the left side of this diagram and probably be all right. But unfortunately, at least with a lot of the projects I've worked on, I've never had anything that's pure Python. So yeah, I want to just kind of talk about a couple of the things I put up here on the graph, just in case folks maybe haven't seen. I'm pretty sure a lot of folks, if you've worked with Python, even at all, you've probably seen a requirements.txt. This is declarative. This is great. It's very simple. It's a list of packages, sometimes with pinned versions or bounded versions. And that really is great if all you need to track is Python. And as we kind of heard with what tools y'all shouted out, often people do end up needing additional tools, because you can have this list of packages and requirements here, this list of packages for this stuff over here. Do you install them all together? What if you have conflicting versions? So that's where like now you have to add the complexity. Even though this file and description is simple, now you've added kind of a bunch of this infrastructure that you kind of have to manage and keep all of these separate. So it's maybe not as simple as the kind of format, declarative format would make you want it to feel like it is. Anyway, on the imperative side of things, you have probably also most certainly used like setup instructions or developer instructions. That's usually when I'm looking at the docs on a new project. Skim, okay, here's the README. All right, where's the developer setup instructions? And those are always really nice because they're easy to write. They should be, even if I'm like just starting something new, I'm keeping notes kind of on the side anytime I do something small to medium sketchy, just so I can add those to the instructions later. But they are really hard to maintain. Like, I know people who, and it's a great actually entry point if you're looking at getting into contributing to open source, just take a project and go through their setup guide, see what problems you run into, if any. But, you know, kind of testing that is a huge task, especially if it's really kind of hard to capture in, say, some sort of CI pipelines. By their very nature, it's a list of instructions, so there are a lot of different ways it can play out depending on what machine you're on. So those kind of give you some good examples of both on the simpler side of declarative and imperative. Raise your hand if you have used Docker here before. Okay, for the record, that is probably 95%, which is honestly more than I expected. That's awesome. I have only started using it a couple years ago, and basically when somebody showed me, I'm like, I can always put things in a box? This is awesome. And now you have this giant hammer that like, oh, do I need to just run this one Python script in you know, my shell? Docker container. Like, I can run it again forever until, so, you know, you can go too far. But they are a great, you know, it's kind of like writing that setup guide for a project, but for a computer. I mean, even this is a very simple Docker file for setting up a Anaconda-based like Python Docker container I'd use. But the verbs here, they're like literally run, copy, they're actions. They just kind of make it really clear what you want the machine to go do to get the operating system ready for you. So given a lot of folks here are already using Docker, I probably don't have to convince you to use Docker, nor is this a talk to convince you to use Docker. Because, yeah, it's supported in most places. A lot of people have probably seen it. It's really easy to hack fixes in because, well, it's just instructions. So anytime you would have added that asterisk in the, you know, setup.md, you can do that in Docker. And they also work really well with dev containers, which is, I gave a talk at last year's PyCascades here about dev containers, which is a cool way to combine your IDE and Docker containers, which is how I started in this rabbit hole. But unfortunately, learning Docker is not a trivial sort of thing. There's lots and lots of kind of, you can make it pretty complex. And sometimes it's hard you don't have Docker where you need to actually develop and run code, whether that's because you're working with students and maybe they have a really, really old laptop that just cannot resource-wise support running Docker, or maybe you're working on edge devices for IoT and they don't have Docker emulation, or you have a corporate policy that says, oh, Docker is a security vulnerability, we can't install it on your machine, but you also can have root access to your shell. I don't know. Basically there are enough reasons why, Docker is a really big hammer. It's a great hammer, but sometimes either you don't have it or you don't have support for it. So you need something else to kind of fill in that gap. And it's also a negative that you can hack fixes in, because then the whole thing is it generally would be like introducing side effects into your environment construction, because things might happen that even though you've listed these steps, maybe in how it goes and does those, it actually downloaded something else and then didn't track the version for that, and now you actually can't reproduce that environment. So that's kind of like one of the biggest things that makes, Docker is pretty reproducible, but that's kind of one of the biggest ways that it can fail that, just because it is a list of instructions, not where it needs to get to in the end. And that's kind of where I got to of feels like something is missing here. And if we're just in terms of filling out all of our quadrants, we have this kind of higher level, system level sort of description, but in a declarative language. So after having spent a lot of time looking around on Reddit and other Stack Exchange and places for something to fill, because I was looking for something like this, I happened across Nix. And so Nix is a language for declarative environments, and it's both fairly new but also pretty well established. There's a lot of this is a pretty popular packaging tool in some other programming language areas, and especially in the Unix communities. But basically, Nix is the language, and then there's kind of three parts to the ecosystem. There's a package store, so just kind of like pip or npm. Nix packages hosts their own package store, which has packages across languages. They have Rust crates, they have npm, they have gems, they have pip packages, they have, apt-get, like Ubuntu packages. Literally, the idea is that it's kind of a global package manager for describing anything, from your operating system up. Which is then correspondingly perhaps why there's also the notion of a NixOS or a declarative computer operating system. So effectively you can take that same sort of idea of having a text file that says, I would just like my machine to have these programs and have my shell configured like this. It will bootstrap itself up from basically just the Nix package store. And lastly, the other piece to it is the Nix shell sort of executable, and that's kind of where, as a developer, you probably will interact with it the most, because that's where you're actually going to be declaring environments and kind of using that to help package your projects. So as an example of that, Nix shell, you install it just like any other sort of command line tool, but you can, it feels obviously also like pip, because pip is a package manager, but if you would run something like nix shell -p for package and say Python 3, maybe this is like, I walked up to my colleague's machine, they just opened it out of the box, they're still kind of provisioning it. I need to show them something really quick, but they don't have Python installed on their system. They have Nix installed though, because I asked them nicely. They heard me at lunch and they were like, all right, Sarah, please, I'll install Nix, that's fine. So I can start the shell session and it will actually download and install Python kind of in the same way that you might see like Docker builds go by. So it pulls in it actually uses internally some of the same OCI container infrastructure that Docker does. So that's a nice plus that we'll talk about later. But it basically goes through and downloads the pieces it needs, caches it appropriately, and then gives me a shell that has Python installed. And when we close this terminal, the machine won't have Python installed. And so it's just a really kind of nice, clean way to keep things, it's like having virtual M's and stuff, but for everything in your shell. And maybe a little bit simpler than you can have, of course, shell profiles and path, and there's lots of ways to kind of get to the same result here, but the idea of being able to just declare that in a text file as a part of my project, at least to me, seemed kind of attractive. And so like, what would that look like? If I were making a Python project here, this would be, probably the start of my declarative system-wide requirements file. Or here, I call it shell.nix. You can call it whatever you want. But yeah, you can see here, I'm just going to say I would like the Python 3 package installed with these other package. I want pandas and requests. And that's it. And so basically what you can hook up Nix shell to things like pipenv, so that when you go into that directory from your command line, it would just automatically switch to the Nix shell that already has everything, all the project dependencies pre-installed and set up, and if it's been cached, or go ahead and do that when you move into the directory. So I don't know, it seems, I was pretty stoked when I saw this. I'm like, this seems too good to be true. And I work a lot in VS Code. It's kind of been my daily driver for a long time. And was also very happy, just as a side note, to see that there's a lot of good Nix tooling in VS Code and in some of the other popular editors and stuff too. So it's not like you're just gonna have these weird looking text files somewhere and you have to get a bunch of other tools to help you work with them. They're really kind of the same sort of first-class citizen as any other framework, like the Docker extensions and stuff that would help you in VS Code. So to kind of summarize my hyperfixation lately. Why would I say give Nix a try? Because it's a package manager that covers your entire system. You can describe an entire computer in a text file. And it uses the similar container infrastructure, like I mentioned, OCI compliant containers. So you can actually connect them to other Docker containers. You can run Docker in Nix. You can run Nix in Docker. Like, it's actually surprisingly, I mean, it's still complicated, but from an infrastructure engineer standpoint, it's still actually pleasant. And from the standpoint right now, it's not as widespread, so that's partly why I'm giving this talk, is to let people know about it. And like a lot of declarative approaches, it's harder to write a declarative environment at the get-go, but once you do, then it's a really good resource and it's much easier to maintain because you're like, I already have described what I need. So what should you choose? In a vacuum, I would totally go entirely declarative. Since the primary tool I know available for that right now is Nix, it would be Nix. But what I would propose or share with you is actually to give kind of a combo a try. If you're used to just kind of putting everything in Docker containers, try starting describing your project in as a Nix file, and then basically when things get too hard, whether it's because you're missing a package or maybe something isn't, like the packages for some reason aren't talking or whatever, anytime you hit like a roadblock and you're like, I'm about ready to give up, then just combine it with Docker and kind of use Docker to then write out the steps you need to finish preparing the environment. And so that's why I see them as really natural complements. It's not like an either or. It's just something that helps, because I can take that Nix environment file then and run it outside of Docker, and I don't necessarily need Docker, and I can give that to someone who maybe doesn't have that. So as a very brief, here's what I've been up to lately. My partner and I have been moving, because we have a home makerspace. We've been kind of trying to set up our own home server for a bunch of open source projects like Home Assistant and whatnot. I promise this is not what my home lab looks like. We actually did install smoke alarms. Not that there aren't things on fire. I have a laser cutter. But we needed it to be portable across devices, because we started by actually having this on our leftover Raspberry Pi hardware. Then that started getting way too hot and was a fire risk. So we actually then ended up got a NUC and a network storage thing. So it's kind of just been growing, but we wanted to make sure it was something that was really easy to port and move to different places. We needed it to run a bunch of different Docker containers for those services. And it needed to be really easy to back up, because as we tinker with this, we needed a safe way to roll things back when we inevitably break them. So what we decided to do was, after kind of playing around with Nix for some of our Python projects, just said, all right, let's actually try it. We're going to go with NixOS, and we're going to describe our, NUC, the little computer that's actually going to run all of our home infrastructure, just from, it's approximately 5 text files. I split it up just because it was nice. Like, here's the networking one, here's the one with the services, here's the backup one. And we're definitely still learning, but basically that's to give you a taste of what that looks like. Here's the start of the NixOS file here that generally they arrange them starting with describing the hardware. So you can see here it's getting into some of different boot variables, time zones. We have tailscale set up for everything for networking. And literally that's all I have to put in there, and it knows that, oh, I need tailscale then, and I will install and set up tailscale as a service. I can declare users. I can just say, oh, I'm going to have a user on this machine. I'm sure you've probably all done the user add, stuff like that. But to just kind of have it declared at the beginning, and here are the things that you're going to have installed. What got me super excited, though, was, because I also spend a lot of time, probably not unlike a lot of you all, configuring my shell and prompts and things like that, and had 1,800 different versions of, I tend to like Starship right now and New Shell, but trying to get that the same across all my machines was really annoying. But now if I describe them in my Nix, and in this case actually literally in the same file that describes my operating system, from the get-go, it's just exactly how I want. And I don't have to kind of tinker with anything after the fact. So there's a part to NixOS called Home Manager that is kind of like how you would set up and configure things kind of in what you'd think of as user space after the OS is built. 1 minute. Oh man, I'm doing so good on time. We made it. See, look, I even put a note. Yay. So kind of key takeaways. When you're working on reproducible or want to make things reproducible, think about making sure you have both kind of declarative and imperative. I mean, if you can do it all declarative, great. But probably you will need a combination of the two to accurately describe or to make your project the most reproducible you can. Docker is great. I love Docker, but it can have some drawbacks, hard to maintain. People might not have it that you want to collaborate with. And Nix is kind of an interesting project, that open source project that fills the gap between the two. And the whole point of this talk was actually because I really wanted to show you this GIF. If you've ever seen the American Office, Michael Scott just goes around yelling bankruptcy as if that's what you could do to declare bankruptcy. So in my head, anytime I'm declaring environments in my head, I'm just yelling, environment! So yeah, thank you so much. And hope you have a great rest of your conference.